Hey guys, so I am here to give you a quick recap of some of the stuff that's going to be on your quiz. So starting with a graph. This is number 4 from the quiz 2 review. And what we want to do is come up with the parent function of this logarithmic equation. The parent function is just log base 5 of x. We could put y equals. Logs can be tough to work with, so I like to rewrite this immediately as an exponential equation. So to do that, you circle up. We're going to do 5 to the y equals x, and you make your chart based off of this. So another way to think of it, though, if you want like a shortcut and you're good at memorizing, the trick is this. Whatever this base number is, in this case it's 5, your x values are going to be 1 over that number, the number 1, and then that number itself, okay? The y values are always -1, 0, and 1, and this is just to come up with the original graph. So we did a problem in class. The base number was 3, so look at my x values to start before I moved it. They were 1 over 3, 1, and 3. So whatever that base number is, that could be an easy way to figure out your x values. What you really did was this. If y is -1, then I plug in here. 5 to the negative first is 1 over 5. That gives me the x. Okay, 5 to the 0 is 1. That was my x, was 1. And then when y is 1, 5 to the first is 5. That gives me my x. So that's what we really did, but we kind of used a trick. Now, again, this is just the original graph. I then need to move it. So this +2 is not in parentheses. If it's in parentheses, this would go left 2. Okay, don't forget to do the opposite. But this is not in parentheses, so this actually goes up 2, which affects my y values. I'm just going to take all my y values and move them up 2. So -1 up 2 goes to +1. 0 up 2 goes to 2. 5 up 2 goes, 1 up 2 goes to 3. So my new ordered pairs are these: 1/5, 1, 1, 2, and 5, 3. Now, all log functions have vertical asymptotes, and those vertical asymptotes default at 0. The asymptote does move with the function. So if it defaults at 0 and the function moves up, then yeah, the vertical asymptote moves up. But if it moves up, it doesn't actually go anywhere because it's just moving up and it's already vertical. Now, if the function did go left 2, then the vertical asymptote moves to -2. If the function goes right 5, then the vertical asymptote goes to the right 5. So it only moves if the function moves to the left or to the right. Okay, but right now it did not move to the left or to the right, so it defaults at 0 and it stays there. Now I just plot my points. My points are 1/5, 1. So, I mean, just draw a dot close to 0 and on the x and 1 on the y. 1, 2. 5, 3. And give me a nice logarithmic looking curve. A logarithmic looking curve is like this. It looks kind of like a square root function, but arrows both ways. If it did ask for the domain, which it doesn't, but if it did, it would be 0 to infinity. Remember, the domain starts where the vertical asymptote starts. And then the range for all of these is -infinity to infinity. So that is just a recap on the graphing. We are going to move on. I said I would do some solving problems. So I am going to do number 25. Okay, so for number 25, we want to make the bases match if possible. So can 2 and 32 both be written as the same base? The answer is yes. 32 is 2 to the 5th power. But that's still being raised to the x plus 4, so I do have to distribute the 5 to the x plus 4, which gives me, on the left, 2 to the x plus 8 equals 2 to the 5x plus 20. And then I can just, once I have the same matching base, I set my exponents equal. And then I solve, so I get x by itself. So I subtract over 5x. X minus 5x is negative 4x, and 20 minus 8 is 12. When I divide both sides by negative 4, I get x equals negative 3. All right? That's the answer. So then taking a look at something like number 26. Let's do this one because unfortunately for us, I cannot make the bases match. 2 and 5 will never end up being the same base on any manipulation. So that means I have to natural log both sides. So I natural log the left and I natural log the right. I then am going to take these exponents and I'm going to drop them in front. This is just using one of the properties of logarithms that I can take any exponents and drop it in front. So I have a 3x natural log of 2 equals, when I drop a binomial down, I've got to put parentheses. And then I have the natural log of 5. And I am allowed to distribute a log only when there's a number after it. So since there is a number after the log, I can distribute, which means on the left, I still have the 3x natural log of 2 equals x times the natural log of 5 plus 3 times the natural log of 5. I just distributed the ln of 5 to both the x and the 3. And now I need to solve for x, but the problem is this, there's 2 of them. So if there's 2 x's, we want to get them to the same side. So 3x times the natural log of 2, subtract over the x natural log of 5 to the left. And that is going to equal the 3 natural log of 5. Now I have 2 x's on the left, which means I can factor it out. When I take out the x, I'm just left over with anything that's not an x. So 3 natural log of 2 minus natural log of 5 equals 3 natural log of 5. And last, but certainly not least, I have to get x by itself. So I'm just going to divide over this parenthesis to the other side. It's going to go underneath the 3 natural log of 5. And that gives me my final answer. 3 natural log of 5 over this parentheses, 3 natural log of 2 minus natural log of 5. That's the answer. Now, I could get a decimal approximation by just typing in that fraction. Alpha y equals, enter, 3 ln 5 over 3 ln 2 minus ln 5. ln being natural log, and that actually gives me my answer as an approximation, 10.7 or 27. I'm cool with you guys just leaving the exact answer, but that's how that problem is done. Okay, so last couple problems, I want to do our log equations. So for log equations, you just need to get the log part by itself, especially if there's only one log. So if there's only one log, I need to get that on its own, which means I need to get rid of 2 things here. I need to get rid of this minus 10 and this 4. So here's how I'm going to do that. I'm going to start by adding the 10 over. So I get 4 log base 2 of x plus 9 equals 16. And before I circle up, I'm going to then, I still have to get the log alone, so I'm now going to get rid of the 4 by just dividing it over to the other side. Log base 2 of x plus 9 equals 16 divided by 4, which is 4. Once the log is on its own, you can circle up. So 2 to the 4th equals x plus 9. If you don't know 2 to the 4th, no worries, use your calc. Notice I'm just typing in 2 to the 4th, it's 16. So you can evaluate that part in your calculator. I'm gonna shrink this down. So I get 16 equals x plus 9. And I'm trying to get x by itself, so I just subtract over 9. So 7. If you don't know what to do, I suggest looking and asking yourself, can I circle up? Because chances are you can, especially if there's just one log. Now, 30 has 2 logs. That's a problem. I need to get them together. If I just have 1 log equal to 1 log, then I can set things equal. That's like in 31. So if we have time, maybe I'll do 31 as well. But for 30, I need to get the logs on the same side. So I'm going to take this negative log of x plus 3 and just add it over to the other side. That's how you move things in math. You add it over or subtract it over. That equals 1. So then I multiply. When I condense, I either multiply the things together or I divide, and it depends on this sign. So since this is a plus, it's multiplication. So log of x parentheses x plus 3 equals 1. I'm going to distribute this x. And I think a lot of students would get stuck here. So when you're stuck, ask yourself, can I circle up? There's only 1 log, which means you can. So it's going to be 10 to the first. I'm going to write this up here. 10 to the first equals x squared plus 3x. So 10 to the first is 10. So I'm going to subtract that over. I get 0 equals x squared plus 3x minus 10, and I'm just going to factor that. Come on, it factors to x plus 5, x minus 2, and then I solve. So I set each one equal to 0. I get 2 answers, -5 and +2. Unfortunately, one of those doesn't work. You cannot log a negative, so the negative answer gets thrown out, and we keep x equals 2. Okay, so that's the answer. I'll do 31 just because it's not too long and it's condensing as well. So it's also condensing. However, in between the 2 logs on the left for 31, there is a minus sign. So that's why I wanted to kind of quickly do this one. So when I condense these, I have to make it a fraction because of the minus. The subtraction implies a fraction. So the x plus 10 is on top, and the 2x minus 1 goes to the bottom. And that is equal to log base 6 of 4. So then the other reason I wanted to do this is because when I have 1 log on the left and 1 log on the right, it's kind of like they cancel each other out. And you can just set the parts that come after equal. So how do I actually solve for x? Well, I have to multiply over this 2x minus 1 and distribute the 4. Here, these cancel. So I get x plus 10 equals 4 times 2 is 8x minus 4. Add this 4 over to the other side. We get 14 equals, subtract this x over, we get 7x, and then divide. So x equals 2. That's how it's done, my friends. All right, so the problems that we did not do in class, I would love for you to try to finish as practice. The answer key is posted. Make sure you guys study, and hopefully this video is helpful.